Let's start as we always do with reference images. Find one that is fairly straight on and save it. Open Blender and get rid of that cube. Click to select it and X to delete. Hit 1 on the number pad for front orthographic and bring up an Add menu with Shift A. Add a reference under Image and select your reference image. Press F2 to name it. Over on the Image Data tab, switch Depth and Side to Front. Check Opacity and bring it down to 0.2 or lower. Next, add a cylinder and make it 12 centimeters tall under Dimensions on the Item tab of the N panel. Let's rename it as Jar. Meters will be the default unit of measurement. Click the Scene tab in the Properties editor. Expand Units and change Length to millimeters. Now double check the jar's size. Select the reference and hit S to scale it down to the height of the cylinder. Next, select the cylinder and scale it only on the X and Y axis by tapping Shift plus Z after hitting S for scale, and match the widest portion of the reference jar. Apply the scale by tapping Ctrl A. This will prevent modifiers and measurements from acting unpredictably later. Now we can tab into edit mode. Use Ctrl R to start adding edge loops around the cylinder at the high and low points of the jar. Tap 2 on the top row for edge selection mode. Select edge loops by alt-clicking them, then scale them up or down to match the reference. If you find that a loop has been placed inaccurately, double-tap G to slide it along its connected edges, or grab it using G followed by Z to constrain its movements to the Z axis. Sometimes it is more convenient to select face loops than edges. Pressing 3 on the top row enables face selection. Now, alt-click between faces to select a face loop. This midsection needs more even density. Press Ctrl R over the area and scroll up on your mouse until the faces are roughly square and click or tap Escape. Click and hold with your scroll wheel and rotate around to view the bottom of the jar. Select the bottom face and tap I to inset. Move the mouse until there is a ring of squarish faces. While in front ortho view, select the lowest edge ring and press Ctrl B to bevel it. Scrolling up will add more loops. 2 or 3 should be enough. Just try to roughly match the shape of the reference. Orbit back to the bottom face and inset one more time, about the same amount as before. Hit Shift R to repeat a few times and delete the center end-gon with X followed by F. Select the ring around the hole. Press Ctrl F followed by G for grid fill. The 1 key on the top row will enable vertex selection. Select the center vert here. Tap O or the proportional editing button to enable proportional editing. Select sphere as the fall-off type. Tap G for the grab tool, followed by Z so that we can move the vertex upward a bit. Scroll up until the circle of influence is grabbing only the vertices we need to create a rounded depression in the base of the jar. Click when done. If, like me, you completely negated the neck of the jar while shaping the rest, it's time to fix that. Select the top face and press E to enable extrude. Move the mouse up and click when the neck is tall enough. Move it up and down with grab in front ortho view to get it just right and delete the face. Tab out of edit mode. That's it for the basic shape of the jar. Now click the modifiers tab and add a solidify modifier. Make the thickness something between 1 and 2 millimeters. If the faces are expanding outward, make it a negative value. It may help to switch to X-ray view by pressing Alt-Z with the cursor in the viewport. Alt-Z again switches back. Another visibility tip is to go into local view. You can do this on any object by pressing slash on the numpad. Pressing slash again will go back to normal view. Now add a bevel modifier. Make the amount something like 0.5 millimeter and change the segments to 2. Right now the modifier is just selecting edges to bevel based on this angle amount. 30 degrees by default. Change that to weight. Tab back into edit mode and select all loops that would appear sharp or tightly curved. Set their mean bevel weight to 1. Now the modifier only bevels the edges we marked. Tab out of edit mode and add a subdivision surface modifier, also called a subdiv modifier for short. Set it to 2 and right click the jar to select shade smooth. In order to make the threading on the neck, we need to make the geometry created by the solidify modifier real and editable. To do that, press the down arrow on the modifier and click Apply. You must be in object mode, not edit mode, to apply modifiers. Now we need to add threads to the neck of the jar. Back in edit mode, select the ring of faces that make the outside of the neck. Press P followed by S. This detaches the selected faces and creates a new object. Tab out to object mode. Select the new object and tab into edit mode. Remove the bevel modifier. Add 3 edge loops and select this edge. Press E to extrude and press X to constrain its movement to the X axis. Select this new face and hit Ctrl I to invert the selection. Delete all of these faces. Select the edge we started with and delete it. You should be left with 3 edges. Tab over to object mode. Add a screw modifier and drag it to the top of the stack. Set the screw height to something like 7 millimeters. Set the number of steps to 34, the same as the sides on the jar, plus 2 for overlap. Press 7 on the numpad for top-down view and turn on wireframe in the overlays menu. Increase the angle until the vertices of the threads line up with those of the jar. With the thread object selected in object mode, apply the screw modifier, shift select the jar, and press Ctrl J to join the meshes again. If your shading looks messed up, kind of like this, you'll need to recalculate your normals. Tab back into edit mode, select all faces here, and press Shift N for recalculate normals. Select the top edge loop of the thread, as well as the top outer loop of the neck. Shift click or Control box select these edges to deselect them. Press Ctrl E and L to bridge the loops. Do the same to the bottom and between the two at the overlap. It may be getting hard to see just what is going on with all of the smoothing. The subdiv modifier can be disabled for the viewport by clicking here. You can do the same for the bevel too. Now we can fill these holes with faces. Select the edges that need a face and tap F. We need to fix the 2 n-gons that we have created. Press K to start the knife tool. It will snap to vertices and start a new cut each time you click. Right-click lets you start a new cut when you need to cut from a different point. Enter completes the cut. Now we can mark the loops around the thread ridges for bevel and add some loops to the inside of the neck to square things up. In order to create the lid, we will add a new circle. But first, tap Shift S for the 3D cursor menu. Click Cursor to World Origin. So with our viewport in front ortho, click the View tab on the end panel and drag the 3D cursor's Z position up to about the top of where the lid will be. Holding Shift while doing so will allow you to be a little more exact, or you may need to type your exact position once it's close. Add a circle in object mode, give it 256 sides and name it. Scale it just a bit smaller than the lid, apply scale, and tab into edit mode. Select all edges or vertices and extrude them downward. Delete all but 3 of the new faces. Add an edge loop near the bottom, select all faces but this one, and extrude them a bit using Alt-E to extrude along normals. Use Edge Slide to move this top edge down a little. Delete these face loops, leaving just these. In object mode, add an empty. Any shape will do, just don't scale it. Rotate the empty on Z by 2.8125 degrees. 2.8125 because we will duplicate this small segment of the lid 128 times to create the ridges around the lid. 360 divided by 128 equals 2.8125. Select the lid and add an array modifier. Set the count to 128. Uncheck relative offset and check object offset. Select the empty as the target object. Check merge so that our segments merge where they meet. And check first and last copies. The merge distance needs to be very small. 0.05 millimeters should work pretty well. If at this point you don't have a ring of a jar lid, you'll need to apply your scale. It also appears that we may have deleted more than we should have when we were deleting our faces. So tab into edit mode and find the missing face, which is probably this one. And we'll fill it, select this edge, right click and select subdivide, And that has subdivided this into two segments. We now have a vertex in the beginning in the middle that we can grab. And we can turn on our snapping, turn it to vertex, and move it on the Z, snapping here, and move it on the X and Y, and snap it to this so that it's just below it. Now all of our little ridges around our cap have been filled in. Tap period or click here to change the transform pivot to be the 3D cursor. Now, when we select these top edges, extrude, and scale on the X and Y, they will scale toward the 3D cursor, not toward the middle of the selection. Just scale enough to get some squarish faces. Use extrude and scale to do the same on the underside before applying the array. Selecting the rings we just scaled, press Ctrl F, followed by G for a grid fill. If you would like to add threading to the lid, you can follow the same steps as before. However, this area will not show to the camera if you're creating the same exact scene that I am. So I'm not going to do that just now. At this point, we may want to re-enable the modifiers on our jar object, as well as go into edit mode and turn on X-ray in the lid object and scale it a little to match the image better. I'm also doing the same to the jar so that everything kind of fits together better. Of course, one last thing that we need to do to this jar before moving on to making the peanut butter is to add a bevel modifier. A very slight bevel modifier, but any realistic object does not have edges that are this sharp. Any edges that are this sharp will stand out as being unrealistic in the final render. Tab into edit mode on the jar and select a face loop on the inside. Press Ctrl+ on the numpad a few times until the area of the jar's contents has been selected. Shift D to duplicate and P to separate the selection. Enter edit mode on the new object and select all of the faces if they are not already. Use Alt S to scale them all on their own normals just a tiny bit. They need to intersect with the jar just slightly. Change the transform pivot back to median point so we don't confuse ourselves. Select the top edge loop, extrude, and scale a small amount, then grid fill. Before we move on to making our materials, we should give our lid a subdiv modifier. We need to add a handful of supporting edge loops for that to look good. So add one here, here, and here. Now, shade smooth and add the subdiv. We're going to need some texture sets for our materials. Preferably textures that are free to get, free to use, modify, and distribute. Start by navigating to 3dassets.1. We need 3 texture sets: plastic, tile, and marble. Pick some that you like and download them as 4K textures. Pick a lower resolution if you really don't have the memory. The 3 I am using are linked in the description. Once you have downloaded them, it is time to hop back into Blender. Make everything in your scene visible. Select the reference and tap M. Select New. Name this new collection something like Hidden. Find the new collection in the outliner and disable it by unchecking its checkbox. Back in the viewport, press Z followed by 2, or click Material Preview. Open up a shader editor by grabbing a corner of the viewport and dragging it away. Select Shader Editor from the dropdown, select the jar, click the New Material button, and name the material. You can simplify the following steps a bit by making sure the Node Wrangler add-on is enabled in Preferences. You can still add all of these nodes without it, it just simplifies the process and is what you will see me using here. Click the existing principled BSDF node and press Ctrl-Shift-T. Navigate to where you downloaded the plastic textures and select both the roughness and normal maps, picking the GL normal rather than the DX if you have a choice, and click the blue button. You can see that this has already connected our textures to the shader for us, along with the mapping and coordinate nodes, a normal map node, and it has set the normal map texture color space to non-color. You'll need to add and set these individually if you are not using Node Wrangler for some reason. Now, make sure that the base color on the principled BSDF is completely white and that transmission weight is set to 1. Since we have not unwrapped UVs, we can use the object coordinates and set the image to box mapping. Then adjust the blending if you see any seams on the jar. We can also add a color ramp between the roughness map and the shader node in order to further adjust the look of the plastic surface. Node Wrangler lets us Control-Shift-click a node to see its effect. Select the lid and assign it the same material from the dropdown. Click this number 2 so that we are working with a new copy of our plastic, and give it a color. Also, take the transmission weight back down to 0. In order to add our label, we need to select the faces of the jar where the label should be, duplicate them, and separate them to a new mesh. Then make any needed adjustments. Now, let's add a few modifiers to it. The first is a shrink wrap. This should have a wrap method of nearest surface point, a snap mode of on surface, the target should be the jar, and an offset of 0.3 millimeters. Next, add a solidify. Give it a thickness of 0.04. It just needs to intersect the jar in one direction and be above the surface in the other by just a little bit. We will add a subdivision surface modifier to this, but we need to bevel the edges first so it does not round everything out. So add a bevel modifier with default settings except the bevel amount. That needs to be very small. 0.001 should be good. Now we can add our subdiv. Last but not least, add a smooth by angle modifier. This is really only needed if you find that portions of the label have dark areas in the surface shading. Tab into edit mode, select all faces, tap U for unwrap, and click conformal. Open another editor and make it a UV editor. Click these two arrows so that what we see here and in the viewport are always synced. Click the X next to the material for the label and add a new material. Start by dragging our label image into the shader editor. If you are using mine, there's a link in the description. Select the image node and press Ctrl-T to add our mapping and coordinate nodes. Change repeat to extend and connect the texture to base color and to roughness. Over in the UV editor, use grab and rotate to position the UV island over the label until it looks right in the 3D viewport. Drop a color ramp on the noodle to roughness. The color ramp should also connect to the height of a bump node set to a very low strength and over to the normal socket. Add a noise texture with a fairly high scale value. We want this to add an uneven look to the bump and roughness of the label. So drop a mix color node on the noodle between the ramp and the roughness and set it to screen. Make sure to replace the connection to the bump with this as well. The surface texture on this should be very subtle. It is just glossy paper after all, so play with the height and color ramp values until you can just see the effect. Now we need something to sit this jar on. Return the 3D cursor to the world origin and add a plane. Make sure to apply scale if you change the scale after creating it. This will affect stretching in the textures. Create a new material for it. Use Ctrl-Shift-T again to add your marble textures. Use the roughness, normal, and base color, also called diffuse or albedo. These terms are actually two different things, but won't matter for this case. Adjust the scale on the mapping node, and it's good to go. Now let's take a look at what our lit scene is looking like. Press Z in the viewport, followed by the number pad 8, or click rendered. As you can see, we have no light. A quick and easy way to get some realistic lighting is to use an HDRI for our world. To do so, first we need to download an HDRI image. Open a browser and go to polyhaven.com. Scroll down and click HDRIs. We want an interior location. I like having a mix of natural light and incandescent light. Here's the one I used. There's a link in the description. Click the image you want, select whatever resolution you want, select HDRI and download it. Why just whatever resolution you want? It's because we will not be seeing the image directly in our scene. We just want to light the scene and give our surfaces something to reflect. Back in Blender, click the World tab in Settings. Click Color and select Environment Texture. Anytime you see this pink color in Blender, be it from a light or on a surface, it is because an image is being referenced, but the image file has been renamed, moved, or corrupted. We haven't assigned our image yet. Click the Open Image button and select your downloaded HDRI. And just like that, things are looking pretty good. Except that it looks like we forgot to give our peanut butter a material. Select the jar and tap H to hide it. Select the peanut butter and give it a new material. Just set the base color to a light brownish color. Here's the hex value that I used. Once done, hit Alt-H to unhide everything in the scene. Now we need a point of view from which to look at our scene and render it. For that, we need a camera. Go back to front orthographic view and add a camera. The camera will be facing whatever direction you were looking in the viewport when you added it. Press 0 on the numpad to go to camera view. While the camera object is selected and you are looking through it, the best way to move it around is on its local coordinate axes. So once you press G to grab the camera, double tap the X, Y, or Z axis you want to move it on. I also like to set my transform pivot to the 3D cursor for this so that rotating always revolves around the subject. At this point, you may not like the direction from which the HDRI's primary light is coming from. Change the shader editor from Object to World. Tap Home if you can't see where your nodes are, and click on the HDRI image node. Press Ctrl T. Use object coordinates and rotate the HDRI on the Z axis until your scene looks right. So far, we've left out the backdrop of our scene so that we can easily see the HDRI rotating while we adjust it. Add a plane and orient it. Switch the shader editor back to object and make a new material. Slap those tile textures on there and scale them. Now, depending on the HDRI in use, the lighting may not be great just on its own. Add an area light as our fill and use it to reduce the extreme shadows. Mine is positioned directly above and is pretty big. The bigger a light is, the softer the shadows it will cast. Adjust the direction and intensity of both the primary, that's the brightest spot on the HDRI in our case, and fill lamps until the scene is looking realistic. Avoid lighting it directly from the camera's direction. That will kill any shadows and realism along with them. One last light is needed. We need to light up the darker edge of the jar from behind with a rim light. This is usually quite bright, and I often use a spotlight because the effect of it is pretty well contained in a target area. I'm using an area lamp that is scaled to be pretty narrow. However, this is still lighting up the rest of the scene too much. Anytime a light should only light a few things, we need to use the light linking features in Blender. To do so, select the light, go to its object settings, and expand shading, as well as light linking. Click New to create a new light linking collection, and drag the objects to be lit by this light into it from the outliner. Anything in this collection will be lit by this light. Everything else will ignore it. Select the camera and click the Data tab. Find Depth of Field and check the box. Click the eyedropper next to Focus on Object and select the label. Now, slowly adjust the f-stop value upward until the jar, lid, and especially the label are in focus. Adjust the final position of all the objects and get ready to render. Let's give our finished scene a render. Click the Render Properties tab. Set your device as GPU compute. Change your max render samples to something like 32. And check denoise using optics for the fastest results. Next, click the Output tab to set your image resolution and image type. Time to render. Press F12 and watch the magic happen. When complete, save the image with Alt-S. And that's it. Since this tutorial covers the creation of an entire scene, I was not able to spend time explaining every detail of every aspect. So ask your questions in the comments and I'll do my best to answer. I hope you found this video useful. Don't forget to like, comment, and subscribe. Until next time, this has been Carl with Blender Forge. Happy blending!